This is the recording for HEC Project HA-1. As you can see here, the center lines are already drawn for NC Highway 125 and the loop ramp and the off ramp. Obviously what you have on your paper is blank. There are no new center lines drawn. So you will be drawing these in. But by me having them on the paper and on the display here to show you, it'll make it easier for you to understand what I'm talking about. Step 1 says draw new center line using your given parallel offset distance. Distance bridge is moved. So first off, as we went over in class already, your triangular scale provides different scales comparing inches to feet. For instance, for the 50 scale, 1 inch equals 50 feet. So when you're looking at the 50 scale, the 2 tick mark equals 20 feet. The 4 tick mark equals 40 feet, and so on and so forth. You're going to use the 50 scale from your triangular scale to offset the bridge by the appropriate parallel offset distance. This distance is provided in your handout, which looks similar to what you see here. Obviously pay attention to your design number because you're going to use the numbers that are associated with your design number and only those numbers. So everybody's going to have different reverse curve radii, delta 2, parallel offset distance, tangent length between reverse curves, and beginning station for reverse curves. Everybody's is going to vary slightly, so nobody's is going to look exactly the same, which is why you can't use the same numbers as somebody else, which is why you can't work together necessarily on this. I don't mind if you help each other, but don't do somebody else's for them. So be sure that you're measuring the parallel offset distance perpendicular to the current or the old bridge center line. I'm going to zoom in here so that you can see that. Here's the old bridge, and this middle line here is the center line, so that's the one you're going to measure from. But make sure you're measuring perpendicularly from that old center line instead of measuring horizontally across the page, as that's not going to be accurate. The best way to do this is to pick 2 points on the bridge and measure this P distance from those points, perpendicular again, marking the 2 new points to the right of your old center line. So you would pick 1 point probably towards the bottom of the bridge or the old center line, measure perpendicular your P distance, mark that point, then come maybe towards the top somewhere, measure perpendicular, mark that point. Then you'll use your scale to connect these 2 points in a straight line, and you're going to extend this line approximately 500 feet in a straight line, as this is going to be needed later as you're sketching in your curves. Step 2 says to calculate your delta 1 given your delta 2, which is the value off of your handout. Again, make sure you use the correct design number. And it says solve for delta 1 using the following equation, and it lists the equation out. R1 times tangent of delta 1 over 2 plus R2 times tangent of delta 2 over 2 plus X equals P over sine of delta 2. Obviously, you'll have your R1 and R2. Those are provided. Those are your radii for your reverse curves. They're the same for both of them. And you have your X distance, and you have your P distance, and you have your delta 2. So what you're solving for is delta 1. Also, what you're going to solve for while you're doing this is your T1 and T2. And you're going to need this later. Remember that T1 is equal to R1 times tangent of delta 1 over 2, and T2 is equal to R2 times tangent of delta 2 over 2. Step 3 says calculate D using the following equation, and it lists the equation for D, which is equal to T1 plus T2 plus P over tangent of delta 2. Now again, as I just said, you found your T1 in the last step and you found your T2 in the last step, so you have those numbers, and that'll help you solve for your D. And again, this step is self-explanatory. Step 4 says add D to the beginning station of reverse curves to show endpoint of the reverse curve system and mark station on old centerline. So your station 0 is provided on your layout sheet. Everybody has the same station 0. The beginning station for reverse curves is also provided on your handout. Mark this point on the old centerline as this is the PC for the next reverse curve, or for the first reverse curve. You can see your station for reverse curves is listed here. Some of you will have 0 and 90, some will have 0 and 95, some will have 1, some will have 1 and 5. So it's all going to vary for each of you, but you can see on this sheet your station 0 is provided for everybody in the same location, but your beginning station for reverse curves is going to vary slightly among you. Now from the beginning station for the reverse curves, measure the distance D along the old center line and mark that station. So once you've marked your beginning station for reverse curves, measure the D distance that you found just before this and mark that point on the old center line. Step 5 says transfer endpoint from old center line to your new center line. This is the PT for curve 2. Keep in mind when you're looking at your drawing, curve 1 is the one closest to station 0, curve 2 will be your second curve, and those are the only two you're going to draw for NC 125. Now from the old center line, mark a point on the new center line with your scale placed perpendicular to the old center line, and this is your PT for your second reverse curve. So that point that you made when you measured D from your beginning station for your reverse curves, that point that you made on the old center line, take your scale and run it across perpendicular to the old center line, and it's going to cross that 500-foot extension from the new center line of the bridge. Where it crosses that extension, that's where you're going to mark your point, and this is going to be the PT for your second reverse curve, so essentially the end of your second reverse curve. Step 6 says from the beginning and end points of the curve system, measure in T1 and T2 as appropriate. These are the PI points for the two curves. T1 and T2 were calculated in step 2 and should be the same since the deltas should have been found to be the same. From the PC of curve 1, which is your beginning station for your reverse curves, mine is shown here, move a distance T1 along the old center line and mark this point. This is the PI of your first curve, which you can kind of faintly see right here. From the PT of curve 2, move backwards along the extension of the new center line, which was found in step 1, and mark this point. This is the PI of curve 2. So where you marked your PT of curve 2, now you're going to move along that extension of the new center line, whatever distance you find to be T2, and that's going to mark your PI2, the PI of the second curve. Step 7 says lightly draw a straight line connecting the two PIs. This is self-explanatory, so here's my PI2. If I come across to my PI1, you can see there's a faint line that's sketched in there that connects those two. It's going to be a straight line. Step 8 says calculate external distance E for each curve and plot this point. You'll calculate E using the formula from your notes. For precision, you can measure the angle between the two tangents for each curve and bisect this angle with your scale, marking the E distance with the point. So you can see here for my second curve, I've got one tangent coming into the PI, and then I've got the other tangent breaking off from the PI. Now you can measure the angle between those two tangents, which is obviously going to be very big. It's going to be close to 180 degrees. But whatever angle you measure, cut that in half, and then you can come straight out at that half point, and that'll give you the direction of your E from the PI. Then you can mark that distance, you can mark that E point and that's going to help you draw your curve later. You can do the same thing for the first curve. Step 9 says from each PI go a distance T1 and T2 as appropriate. So from PI2 go T2, from PI1 go T1. Along the line drawn in step 7 to get the other endpoint for each curve. So the PT for curve 1 and the PC for curve 2. This is self-explanatory. As you've already got your PT2, you've already got your PC1, now you're going to find your PC2 and your PT1. Step 10 says check the straight tangent length in between the two curves with your scale. It should equal your given x value, the length of the tangent between the reverse curves. If not, recheck your calculations and the plotting of your curves. This distance is going to be verified by measuring the distance between PT1 and PC2. So you can see in here I've got my PC2 and my PT1, so you'll measure the distance between those, and it should be pretty close, if not exactly the x distance that's provided on your handout. Now if it's not exact, that's okay, but it's got to be within probably a couple feet. Otherwise, if you're off by 10, 20, 30 feet, then you may have a problem. You may need to go back and double check and make sure that you've done your calculations correctly. Step 11 says using the PC, PT, and E for each curve, use your flexible curve to draw in the actual curve. You'll leave all lines on the drawing for now. This is self-explanatory, but just to be sure, at this point you won't have many lines on your page besides the extension of your new center line from the bridge, and the old center line will still obviously be on there. So what you'll be doing is kind of connecting the dots between your PT, your E point, not your PI, but your E point, and your PC for both of your curves. Okay, and you want to try to make that as flat as possible. You want it to be very smooth. Use common sense. Don't run a line way out and then run it across your E and then run it back across your PC. You want it to be very flat, very smooth coming across between those points. Step 12 says use the red pencil to trace over the center line of your new alignment from your starting station to the end of the curve system. This is also self-explanatory, but double check your new center line carefully before tracing your new center line with the red pencil, as this cannot be erased and you won't get another plan sheet. Step 13 says neatly identify and label your curve points, your PC, your PI, and your PT for each curve. This is an important step in that it helps me, since I'll be grading your projects, it helps me quickly view your plan sheet for accuracy. This could also very likely result in more bonus points if your drawing is neat. You can see on this drawing the station is listed out with a line connected to the point that it's referencing, and all of these lines are drawn very neatly. The PC and PT for each one is listed very carefully and very neatly, which makes it easier for me to kind of pinpoint those, pull out what they are, and I can actually kind of grade your numbers and not just look at the drawing to see how it looks. With that said, be sure to compute the values requested at the bottom of this assignment as well. You can see that there's values that are requested of you, and those need to be written out on your project sheet, your handout, to be turned in to me. And then you'll be done with HA-1.